Hello, class, and welcome to lesson 4.5, independent and dependent events. So today we're going to start off with the Venn diagram, and we'll be relating to that later on in the unit when we take a look at probability of two independent events versus probability of dependent events. So we'll go over that terminology. But let's start off the warm-up here with this Venn diagram. Hopefully you had something like this on your last unit test, so we're just going to quickly go over it. So, given the diagram 1A, state the number in A. So the number in A, folks, is the number in the entire circle. So you're going to write down 8 plus 3, which equals 11. Okay? Number in the sample, folks, means everything. So all the numbers you see inside, okay, which are inside the square box, I should say. Okay, so it's going to be 8 plus 3 plus 2 plus 6, which equals 19. Okay, let me just fix that 8 up because it looks a little funny. Okay, now we're going to do something new, which is the probability of A. So the probability of A equals the number in A over or divided by the number in your sample. So the number in A from question A is 11, and the number in our sample from question B is 19. Plug in your calculator, folks, and it's approximately 0.58. So probability of being in event A is 58%. All right, let's take a look at D, the number in A and B. Okay, so when you do that, ladies and gentlemen, it's the A and B is the overlap. So which ones are in A and B? And that's going to be 3. Okay. And means to multiply if you're thinking about that. Okay. And then we have E, the number of people in A or B. So this is also going to be written as A or B. Okay. And remember, you add when you have an or. Okay, so that's going to be highlighted with kind of like your binoculars in this case. What's inside this, all the circles? Okay, all right. Okay, so if you add those up, it's 13. Okay, if you use that principle of inclusivity, you may have said it equals the number in A plus the number in B and subtract the number in A and B. Okay, which is the upside down n, if you want to know that, which is what we wrote up here. So this is number of A and B. Okay, so let's do that. So the number in A is 11, right? Plus the number in B, which is 5, and then you subtract the overlap, which is 3. So 16 minus 3 equals 13. Okay, or you just add them up. Okay? All right. Last one. The number that are not in B, okay? Well, that equals the sample, subtract the number that are in B, right? This is the complement method, okay? So number in our sample we know is 19, subtract the number in B, which we just discussed was 5, equals 14. All right, let's keep moving on. Let's get to today's lesson. Okay, so today we are going to talk about what compound events are, okay, and if they are independent or dependent, okay? And then we're going to calculate the probabilities of each. Okay, so compound events, folks, this might be something you want to write down. Compound events are situations that involve two or more events. Okay? So, we could take a look at the probability of eating in a day. Okay? You probably deal with the breakfast, and then you deal with lunch, and then you deal with supper. So there's 3 different ones that are called compound events. Okay? Or you take a look at 4 classes in a day. You go to one, then another one, then another one, maybe you have a spare, etc. Okay, so now we're going to break those down into what's called independent or dependent events. Okay, so independent events are situations with compound events, meaning they occur one after another, where one event has no effect on the other event. Okay? So, example, if I flip a coin 5 times, okay? And I flip it first time, I get a heads. Okay? Does the second time I flip it depend on what I got on the first? No. So maybe I get tails, maybe I flip it again, I get tails, maybe I flip it again, I get heads, and then maybe I flip it again, I get heads. Notice that each time I flip it, it's independent of the other outcome. Okay? All right, so let's do an example to follow that up. Okay? What is the probability of rolling a 4 and drawing an ace of spades? Well, what you want to realize is and represents what? Multiplying. Okay? But you also realize that when you're doing this situation, rolling a 4 means you have a dice or a die. You want to take a look at one of them. Okay? And an ace of spades means you also have to have what? A deck of cards. Okay? So does the outcome of rolling a die affect the outcome of drawing a card? No, because they're separate things. Okay? So this is where we're going to identify each event. Okay? So event A, or outcome A, if you want to take a look at it, that equals the probability of rolling a 4. Okay? Now we'll take a look at event B, which is our second event. And event B is drawing ace of spades. So you can draw it. Hopefully you're a good drawer, maybe better than myself. Okay? So those are your two events. Okay? Now we want to find the probability of it. So probability of A and B, okay, equals the probability of A times the probability of B. Okay? Similar to your similar to your multiplication counting principle that you did with associated with the tree diagram. Okay? So probability of rolling 4. So probability of getting a 4 is 1 out of 6. You guys okay with that? So it's going to be 1/6 times probability of drawing an ace of spades. Well, that's only one chance you can do it out of a total 52. Okay? Plug it in your calculator or just use your fraction button, folks. That's 1/312, which equals 0.0032. So therefore, prob of rolling a 4 and drawing queen of hearts, ace of spades, my fault, is 0.32%. Very low. Okay, but notice that they are independent. One doesn't affect the other. So here's your formula, folks, for probability of two independent events. Okay, all right, and this is a rule for it's the product rule. Produce rule. Product rule for independent events. All right, good. Okay, let's do the flip side. Let's take a look at dependent events. Okay? Sorry, just give me a second for this announcement to be done. Okay, so dependent events are situations with compound events where the outcome of event B depends directly on the outcome of event A. Okay? So, for example, I speed when I am running late. Okay? Or I'm in a hurry. Okay? Alright. So, it's only when I'm in a hurry that I speed, otherwise I'm just chugging along normal. Okay? So, here is our notation. Okay? So, probability of B given A, okay, means the probability of B occurs given that A has already occurred. Okay? So, an example of this, folks, would be if I have a deck of cards and I ask one student to pull a card out and don't show anybody. Okay, and then I ask her to hold on to it, and then I ask another student to pick out another card. Well, the probability of what the first person had in their hand, or that card they picked, affects the second person's probability. Well, first of all, instead of having 52 cards, the second person would have only 51 cards, so that does affect the probability. Okay, so if we have something consecutive like that, that does not have what we call replacement of the cards, then that's what's called a dependent event. Okay? This is also called in your textbook conditional probability. For example, event B is conditional on event A. So I speed, which is event B, when I'm in a hurry. Okay? And that's event A. Okay? So in general, here's our probability formula for this. So the probability of A and B is the probability of A, which happens first, times the probability of B given A. Okay? All right, and we'll do an example here where it should make sense. Okay. All right. So these formulas are on your formula sheet, folks. And I'm not sure. Let me just quickly double check if they actually say independent versus dependent on it. Let's look. Yes, they do. So you don't even have to memorize that, folks. They tell you this is for independent and this is for dependent events. All right, so let's take a look at this next example, number 2. This is a good example to make sure you know how to do, and I've seen something like this on a unit test before too. I'm just going to move it up a little bit and bring it back down. Okay, so Nick estimates that when he walks to school 2/3 of the time when the weather is good, but only 1/5 of the time if the weather is poor. Okay, let's say it's good weather 60% of the time. What is the probability that Nick walks? Okay, so his walking ability is dependent on good weather. Okay, so let's start with our event A. So our event A is good weather, because that's our deciding factor if he walks or not, right? Okay, okay. And event B is that he walks. Okay? And the reason I chose A, it's when he said when the weather is good. Okay? So that is happening first. So he walks 2/3 of the time when it is good weather. That means weather has to be our first event. Okay? Now, it's easiest, folks, to do this demonstration if I choose a tree diagram. Okay? So I'm first of all going to do the outcome of the weather. So either I have good weather or I have bad weather. Okay? Which means not good. Okay? All right, so that's event A. Event B, sorry, I should have done that in blue. Okay? Event B is now we're taking a look at if he walks or not. So walk, no walk, or not walk. Okay? Walk versus not walk. Okay, so we've got our tree diagram set up. Now we're going to put on some percentages. So first of all, when we take a look at, let's say there's good weather 60% of the time. So 60% is good, okay, which equals, if you put into a decimal, 0.6. Everybody good with that? Which means the opposite of that is bad weather, which is 40%, which equals 0.4. Hopefully everybody's good with that. Okay. Now it says that he walks 2/3 of the time when the weather is good. Okay. So 2/3 of the time when he walks when it's good, which means 1/3 he doesn't. Okay. But when it's poor weather, he's only walking 1/5. So 1/5, and the other complement to that would be 4/5 of not walking. All right. How are we doing so far? Good? Okay. So what I want you to do is realize, what is the probability that Nick walks to school? Well, I'm going to show you 2 different pathways. Hopefully my highlighters will work here. Let's see if we can get a nice highlighter. So first path is if it's good weather, guys. Okay, he walks. Okay, my second path to consider is, hey, if it's bad weather, he can walk. So there's two different pathways we're going to take a look at, or two different situations. So in order to feel this out, don't forget we have the top path we could do, or we have the lower path. So you could say the teal or the purple, right? Okay, so probability of him walking, if we do the top path first, is going to be 0.6, right? Times 2/3. Everybody okay with that? Or means to add, don't forget that, the lower path. Okay, so it's going to be 0.14 times 1/5. Okay, so let's get our calculators out, folks. I forgot my equal sign, sorry. Okay, so plugging this in your calculator, you should be able to get 0.4 plus 0.08. Add those together, 0.48. So therefore, there's a 48% chance Nick will walk. Okay? All right. Now, that's just demonstrating the idea. Let's go over now proper notation. Okay, so let's use set notation here. Okay, so probability of walking, okay, equals the probability of good and walk plus the probability of bad and walk. Okay, all right. So taking a look at that, that's going to be relating to our A's and B's that we set out. So probability of A and B, okay, plus the probability of A prime, which means bad. Like if it's bad, it's the opposite, right? And B, okay. So that's the proper notation we're looking for, okay? All right. Okay, and then we sub that in. So you could go 0.6 times 2/3 plus 0.4 times 1/5. And that will give you 0.48. And then you would do your therefore statement. So showing this information, folks, this is your proper set notation here. Okay. 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 And probability is probability of B given A. Okay. Awesome. Okay, let's do one last example. Okay, example 3. On a trip through Mitchell, Brandon has determined that the probability of hitting a red light is 0.7. Don't know if you've been to Seaforth lately, but the lights have been really slow there. He has also determined that there is a 0.3 probability that he will hear his favorite artist, Taylor Swift. Okay? Determine the probability he will A, get stopped at a red light and not hear a Taylor Swift song, or B, not get stopped at a red light and not hear a Taylor Swift song. Okay? Well, hopefully you recognize that these two are independent events. Okay? So let's start with that these are independent events. Okay? Now let's take a look here. Let's take a look at our two outcomes. So our first outcome that's mentioned is red light. Okay. And the second event, which is independent, so it really doesn't matter which one goes first, folks. In this case, I'm just going to do Taylor Swift. Uh-oh, Taylor Swift song. I think I spelled that wrong. All right, so let's take a look. Okay, what is the probability of A? Okay, let's just do that separately. So probability of a red light, okay, is 0.3. 7. So the probability of not red light, because you need to know that, is going to be 0.3. Remember, total probabilities total 100, right? Or 1. Okay. Let's do probability of B. Okay, so probability of hearing a song is 0.3, which means probability of not hearing the song is 0.7. Everybody okay with that? All right, so let's answer these questions now. A, because now we're going to combine them. Okay, what's the probability of him stopping at a red light, so that's A, and not hearing, so that's B prime. Everybody okay with that? Okay, so that's going to be 0.7 times B prime, which is 0.7. That equals 0.49. Okay, we'll do a therefore sentence in a second. Okay, B. B says not getting stopped, so probability of A prime and probability of B. Okay, so probability of not a red light, so it'd be 0.3 times, which is here. Okay, and probability of not hearing a Taylor Swift song is 0.7, which equals 0.21. Let's do some therefores. So therefore, 49% chance of red light and no Taylor Swift. I'll just do ST. TS, sorry. Okay, whereas B, the 21% chance of green means go and other song. All right. So, ladies and gentlemen, I would like you to, after we're done, watch this video. It gives you a little explanation between independent and dependent variables. And a check for independence, I want you to remember this for class and for your module, okay, is that does the probability of B given A equal the probability of B? That tells you, are they independent or dependent? Okay, because if they're not the same, then one depends on the other. Okay? All right. Here's your homework, folks. Page 333, numbers 1, 2, 4, 6, 10, and 17. Have a great day, folks, and see me if you need any help. Ciao, Bella. Bye.